Really, really thrilled to have Hollylynne here speaking to us. Hollylynne, a lot of us, is no stranger to a lot of us. We've followed her work for a long time. Hollylynne is a distinguished University Professor of Maths and Stats Education in the STEM Education Department at NC State University, Raleigh in the US. And Hollylynne does a lot of work around innovative work around statistics and data science education. And we're really thrilled to have you here to share some of your thoughts and expertise with us and with the school community. Over to you. Before I hand over to Hollylynne, just to say we will post a recording and the slides from Hollylynne's talk, and there'll be opportunity for questions at the end, and you might maybe want to, as you're thinking of questions, tap them into the chat as well. Thank you. So over to you, Hollylynne.
Okay, great. Thank you so much. Um, so it is wonderful to be here, a few blocks away from you, here in Auckland. Um, but I have on the map, if you're not familiar with where Raleigh is in the United States, we are on the East Coast. So we are a coastal city. It takes about 2 hours for me to drive to the Atlantic Ocean. Um, and I have been at NC State for this. I'm just getting ready to start my 25th year. So been there quite a while. But I really am honored and humbled to be here. And I really thank you for the invitation and for the opportunity to collaborate a little bit with my background. So I am a former middle and high school math teacher. Um, all my degrees from undergraduate through PhD are in mathematics education, with a little dose of statistics in there in statistics education. But a lot of my expertise in statistics education has developed throughout my career through my own expertise, developing my own expertise, and with colleagues rather than coming specifically from a degree program. Um, I am in a department of STEM education, and I have strong, excuse me, I have strong collaborations with our statistics department. They are right next door to us. I teach everything from undergraduate to doctoral students. So, for example, I, I developed one of the first dual listed courses in our university between math education and statistics, teaching and learning statistical thinking. And it's become a cornerstone course in a couple different degree programs at the master's and PhD level. And then just recently took over teaching a special section of our Statistics 101 class specifically for elementary and middle school teachers. And so it's a data and chance class for those preparing to be teachers of primary and middle grades, which is probably ages like five to six through age 14 in the United States. I am a senior faculty fellow at the Friday Institute, and the Friday Institute is associated with NC State, and it really is our research and outreach kind of arm for our College of Education. And there I am the director of the Hub for Innovation and Research in Statistics Education. I had the pleasure of spending one semester at Baylor University in 2023. But other than that, I've been in NC State my entire career. So we've got several different projects at NC State, and I will be drawing on those as we go through the presentation. So at the core, I really consider myself an educational designer. That's how I approach teaching and learning, that I am trying to think about the ways in which you design learning opportunities for students, and whether those learning opportunities involve hands-on or technological tools. They also include the kinds of questions and the tasks that you choose. And so I think if we think about ourselves as educational designers, it's how I approach even working with future and current teachers, is that that is their profession is to actually design these learning opportunities for students. So this all just to step back and give you a little glimpse, my passion for statistics education and the way I first kind of applied an educational design approach was during my doctoral degree from 1998 to I graduated in 2000. But during that kind of 4 year period, I worked on developing a piece of software called Probability Explorer, where, at the time in the mid 1990s, there weren't a lot of good pieces of technology to kind of enact simulating random events and to actually particularly see graphical displays generating while data was being collected. And so that was kind of my first kind of entrance into thinking about uh, design of technological tools for supporting statistics. And, I did so in my early work, I was very much focused on students learning with these different kinds of tools, and did several different kinds of studies. And all of that led me, oops, I'm not going to play this video because of time. But when you get the PowerPoint, you should be able to actually play the video if you are interested in watching it. But, a lot of my research, looking at students learning with different tools included, videotaping back in the day on VHS tapes when we didn't have good screencasting kind of software. The kind of interactions that students do with different technological tools, and then really studying the affordances and constraints of what that tool was allowing them to do. And so a lot of that has informed a lot of my work with that I currently work on with designing teachers. So in 2005, I started working on a project called Preparing to Teach Mathematics with Technology. So I'm a mathematics educator. We were very much focused on thinking about how do you prepare teachers to teach with technology in general. We started with the domains of statistics and probability, because in the US at that time, there was still, there was not a whole lot of material with that. And we would create video cases, where you can see an example of this in the lower left-hand corner of kids working with certain tools. The one shown there is Tinker Plots. And we would build cases for teachers around this so that the teachers could actually then analyze what the students were doing and saying and talking about when they were using this tool, and how it was supporting or not their statistical thinking. And from that, this particular diagram that's on here, my colleague Karen Hollybrands and I, took a stab at trying to think about, well, what kind of knowledge does a teacher need when they're teaching in a technological supported environment? And so we tried to outline, and we had a paper in 2011 that kind of depicted what we thought was technological, pedagogical, statistical knowledge for teaching. And, a lot of that really stemmed from my work, again, beginning with students, analyzing what students do, and then trying to apply that to, well, then what does a teacher need to be able to know and do in a classroom to help support that kind of learning? So that project continued for quite a while. And it continued to grow, and we created lots of different modules to support teachers learning how to teach with various different technology tools with different content domains, not just data analysis or statistics and probability. And so the website here, you can go and get access to all of these free materials. I'm a huge believer in open access resources. And so, as of February of 24, we had over 1,500 users. The vast majority of them are faculty members in the US, or teachers who do professional development that come into our portal and actually get materials that we've developed to be able to use in their courses or their workshops for teachers. So all of that, so we started with data analysis and probability. We expanded out to lots of different content domains in teaching mathematics. And then in 2016, I paired up with Bill Finzer and Rick Hudson and Stephanie Casey to try to think about hyper focusing on statistics teacher education. At that point in the United States, the comfort level that math teacher educators in the US had with preparing teachers to teach statistics was really minimal. And I think we've only actually made a tiny bit of progress in that in the past 8 years. But what we decided to do was to think about how could we develop materials and package them in a way that would be the easiest way for faculty members to try to integrate those into their courses. So we take them, just like we did with the past project that was generally with preparing to teach math with technology, we took a modular approach, thinking that in the US, across universities, there isn't just one structure for getting your licensure to teach mathematics. And so some universities might have one or two courses where they can really attend to pedagogy. And then other universities might have 5 courses where they can actually work with future teachers in developing their pedagogy. And so faculty have to think creatively on we have to prepare teachers to teach so many different areas. Where do we fit in attention to statistics? And so a modular approach helps to take advantage of and support faculty who are trying their very best to fit things in where they can. And again, these materials are available for free, and they include video cases of students working with different aspects of statistics, and oftentimes it also includes classroom conversations and interviews with teachers who are teaching different statistics lessons, things like that. One of the key aspects of this is that our materials can be downloaded and imported directly into a learning management system. That was one of our ways of trying to make it easy for faculty members to utilize our materials. So this screenshot here actually shows the materials in Blackboard. But Blackboard, Moodle, and Canvas are 2 or 3 of the more popular learning management systems used in the United States. And I don't know if that is similar here to New Zealand as far as the kinds of learning management systems. But we built this using a common cartridge type of application so that it should be able to be imported into any learning management system. But one of the key things with the ESTEAM project is that partnership with Bill Finzer. And what I personally loved about this, I have a long history with Bill. I met him when I was actually a graduate student in the 1990s when he was first developing Fathom. And I'm assuming some of you here have used Fathom back in the day. So I was one of the original beta testers for Fathom. But he and I had been talking about this new thing code app that he had been developing back in like 2014, 15. And I'm like, Bill, if we're going to get this into the mainstream math classroom, we need to add new features to it, because where it was at that time, it didn't have a lot of features that would support teaching the standards or the objectives that you find in a lot of math classrooms. Because at that point, he had been partnering with a lot of projects that were more science oriented. And so they didn't necessarily feel like they needed box plots or linear regression, where we were like, no, I think we need some box plots in there. So the ESTEAM project was able to actually work hand in hand with Bill and think about the design of different features to add into CodeApp, so that it would be more aligned with what math teachers are going to need to teach and the kinds of statistical tools that we need to model different ideas with different kinds of data. And so up here you see the box plots that you can add into CODAP, the linear regression models, and being able to separate data by a certain type and have the linear model separated by that type of by that categorical variable. Being able to have stacked bar graphs and being able to do that with both proportions and counts, and being able to add the sampler. So if you've ever played with the sampler plugin in CODAP, all of that came directly from the NSF funding with the ESTEAM project and our team adding those features to CODAP. So what I loved about this, I joke that it put me in the designer seat and I didn't have to do any of the programming. So Bill and his team did the programming, but we got to actually design how it would work. So at the same time in 2015, I was given an opportunity to think about doing a MOOC, a massive open online course for teachers. And so in 2015, we opened the first course called Teaching Statistics Through Data Investigations. And over the course of several years, we ended up having 7 sections. We would open these courses for about 10 to 12 weeks at a time. And then over a period of time, then it would close, but people would always still maintain access to those courses if they ever wanted to come back and look at the material. There was a lot of demand for diving deeper into ideas, and so we developed the second course on teaching statistics through inferential reasoning. And then we took a lot of the material from the Preparing to Teach Math with Technology and built that into a MOOC on teaching math with technology. And you can see that was an incredibly popular one with over 3,000 teachers enrolled. And then just recently in 2021, we took kind of the best of the teaching statistics through data investigations and the one through inferential reasoning and combined them together and updated them to do the amplifying statistics and data science in classrooms. So all of these were, a way for me to be able to, for free, give online professional development for teachers from around the world. And as you can see, we've had over 106 countries, educators from around the world engaging in that. And aside from the US, I am very happy to report that the next country with the most teachers that engaged in our courses was New Zealand. So we had 117 teachers enrolled in those first 2 statistics classes. The next one after that was Australia. So not surprisingly, you all who have been putting a lot of emphasis in statistics and data science, many of your teachers actually registered and engaged with us in these MOOCs. So a lot of this work, was leading me to believe that, there was this beginning talk in education circles, at least in the United States, about data science and this move to working with bigger data. And, we were already working with bigger data in education scenarios, but it wasn't making it mainstream into the classroom. And I was really inspired by the work by Chris and Maxine that they had done in the 1990s, kind of describing how statisticians work and think. And so I had an opportunity to actually study data practitioners in industry and what they actually do. And I felt like as a researcher, I needed to go and spend some time thinking about what people who actually work with large data do in order to be able to honestly say, I understand what data science actually is. So I got a grant from RTI International that is located in North Carolina, and they bought out half of my time from the university for me to spend time with them. And I had a joint appointment with their Center for Data Science as well as their Center for Educational Technology. And through that, I actually got to study. I went to the weekly meetings. I went to the seminars that the data science group was doing. I got to go and hear their presentations. I did interviews with them. And I also spent time reading the literature on what data science actually is, and approach this both theoretically as well as empirically from the data that I was collecting from my own study. So, theoretically, I was looking at some of the work from statistics education. You can see the diagrams on the left-hand side. The PPDAC cycle is used, came from Chris and Maxine's work, and is still used here in the New Zealand. And the GACE framework in the US used a slightly condensed version of that. But then over on the right were different ways that people were writing about data science and things that were happening in data science. So I used a lot of that work along with the data that I was collecting from my own empirical study to kind of think about what data scientists actually do. So, it will come as no surprise that they really are problem solvers. They're very good communicators. And they learn the skills that they need. They're very adept at learning on the job and thinking about what skills they actually need to do the job that their client needs them to do. They use mathematics, statistics, and computational thinking very readily. They've got a very broad toolkit of things that they draw upon and the tools that they use. And they also develop their own applications, whether it's collecting data, modeling data, or analyzing data, depending on what their client actually is asking of them. So they work in teams, and they have lots of different jobs and roles on those teams. But they all talk about, and I certainly saw this, that they spend so much time immersed in the data. And collecting and processing and wrangling and exploring and visualizing and securing it and sharing it and all of that, with always going back to making sense of the context that data came from. And if they were working with a client and they didn't understand a particular measurement, they would go back to the client to actually ask questions about making sense of the data that was collected that the client had given them. And I was really impressed with this, that data scientists are not just black boxers. They're not just operating blindly on data with no meaning. All right. They are continually staying connected to their context and the problem that they're trying to solve, why they have the data in the first place. So from that, myself and my group at NC State, we wrote a paper in 2022 where we introduced this particular framework. When you get the PDF of the slideshow, you can actually click on this link to see a PDF of this same poster here, this same picture. But the fact that we tried to illustrate this not as a cycle, but as puzzle pieces, and that data scientists go back and forth between these different phases and processes, and that they might be at the stage of considering models for their problem, and they've got to go back to considering data or maybe gathering additional data to be able to support the kind of modeling that they want to do. And so there's a lot of fluidity within the processes that they work on. And a lot of the simple kinds of frameworks, for example, in the GACE framework, even though it says collect and gather data, and then it goes to analyze data, collect and gather data infers that they're also processing data, but data scientists spend so much time organizing and structuring their data that we really felt like it needed to be called out as a separate process so that it's elevated in its purpose and its the time that it takes to actually engage in that activity, as well as the idea of communicating and proposing action. That when you are a data practitioner, that you're trying to look for and solve some type of problem. You've asked questions, or your client has given you questions, and in the end, you have to craft a data story to convey and communicate that to your stakeholders. And you have to kind of think about, communicating that with whatever constraints or potential biases may be in your analysis, and what proposed action, like what is the big so what? Why should we care about what just came about from this data investigation? So all of these kind of work together. And so, I try very hard in my role as a researcher and as a teacher educator to take what I've learned and actually put it in a format that can be used for teachers and their students in classrooms. And I think that many of you here do the exact same kind of things. We're very kindred spirits in that way. And so, this is one example of how we do that. And so, learning from what data science is and the learning that we did when we were doing all the professional development in the MOOCs, we took a step back and really thought about how do we take online professional learning for teachers and take it to that next level. So we were learning a lot in the development of the MOOCs and our analysis of data that we collected through the MOOCs, that there were certain experiences that teachers had in those courses that became that became very important in changing their perspectives or them thinking about some things that they wanted to do in their classrooms. Now, we did, with such a large population, we did not go into their classrooms and follow them into their classrooms. So all of this is self-report through what they talk about in discussion forums, what they told us in interviews, and what they may have responded to on surveys that we did. But we were looking for what we called triggers, different experiences that the teachers had that were triggering changes in their perspectives that could impact the actual teaching environment that they had with their students. So all of that led us to think about online professional learning in a different way. So the InStep project, instepwithdata.org, and if I was with you in person, I have these lovely stickers that I was going to give you all to kind of remind us that there are places that we can go, and you all have built some of these things in New Zealand as well, where we can learn together or on our own in online spaces. And that, we don't, as a teacher educator, I love being in a room, in a workshop with teachers, or being in my university course in person with my teachers. But in the US, a large portion of the United States is rural. All right, those teachers don't have access to high quality professional development, specifically for a very small area of mathematics teaching like statistics and data science. And so while online professional development is not the answer to absolutely everything, it can be useful for supporting those teachers that are particularly isolated and may not have those types of opportunities. So this was funded by the National Science Foundation, and RTI is a major partner with us in this project. And what we've done is we've taken and we've thought about what does it take as a teacher to design an effective learning environment that actually supports students in doing statistics and data science. So as a researcher, we're all about frameworks. You have to have something to frame your work. And so we call this the 7 dimensions of teaching statistics and data science. And we've pulled this from a variety of different research from the stats education community. But around the outside, you can see that, as a teacher, you have to have a sense of what data and statistical practices are. And you also have to have an understanding about central statistical ideas. And those things right there drive and inform the things that are happening in the middle of this framework, the tasks that you design or that you choose to use, the kind of data that you are using with your students or that you're going and having them collect, or the sources that you go to get secondary data, the way that you help the students actually structure that data, the kinds of technology tools that you use to support the work with statistics and data science, how you structure and facilitate argumentation and discourse when you're having conversations about data and students are taking a look at different variables in a large data set and how you actually orchestrate those kinds of conversations. And then the way that you assess and the ways that you make sense of students' learning. So all of those have to come together to actually support that. And we use that framework to help us frame the material that we put in our online platform. So we have two primary pathways that teachers can use. So unlike a MOOC that is set up as a course where you go in, you have chapter 1, chapter 2, chapter 3, and you kind of go linearly through a course, our environment is set up for a teacher to be able to go in and to choose what they need to learn. And we actually have a recommendation engine built into the platform. So we start them out with two different recommendations based on our prior research on that are good starting points. And then they can continue to get recommendations if they answer a few short questions for us. And so based on what goals they have and the kinds of experiences that they've had, we can recommend different things for them. They don't have to listen to our recommendations. But it's a way to guide them through choosing things. But the two primary pathways are to just dive in and do a data investigation. We use CODAP as our primary technological tool. So a teacher can click on, say, the US roller coasters or the census at school. We do use the US version of the census at school for that particular investigation, though we do link out to the international one. Teachers start to engage and be able to start thinking about and feel what it's like to actually engage with larger data using CODAP. We have videos to help support them in that process. And we also walk them through this data investigation using some pedagogy. So for example, with the roller coaster data, we talk about how do you launch an investigation? How do you actually give your students an understanding of the context of the data so that they can make sense of the measurements? And so we actually walk through that in that data investigation. The second kind of way that teachers can learn within the InStep platform is to choose one of the areas from that framework and to go into that dimension, and then from there choose different modules to actually learn from. So for example, if teachers wanted to learn more about data and statistical practices, they can choose to go in there. And this is a screenshot showing actually what one of the modules is. And the system will actually keep track for them the different pages that they visited. We give some time frame because one of the other major assumptions is that teachers are incredibly busy. So we tried to build a tool that you could learn an entire module in about 2 hours or less. And we will keep track of it for you. And we have a system in place that if you log out and leave and come back, it will take you to your dashboard and you have one click to take you back to where you left off. And you can pick up and continue your learning. So, teachers can come in here, they learn about the different data investigation processes in this particular dimension. And they, they can go and do these data investigations that I was referring to earlier, such as looking at big multivariate data like roller coasters, using CODAP to look at the data. So I know that Pip, for example, did a workshop at over in Australia at ICME last week, and she was using a data set of roller coasters that we have that has 157 roller coasters. In the InStep platform, we actually collected new data, and we have 635 roller coasters, and it represents all of the roller coasters in the United States that were in operation in 2020 during COVID. Ironically, we needed some things for our graduate students to do, so we had the graduate students doing some web scraping and getting the data for us for all the different roller coasters in operation, and we're able to create an investigation with that. And again, throughout those, we give different examples of pedagogical moves for helping students. So, for example, we have different video cases of students working and with the same roller coaster data set, and you can actually hear the kinds of conversations that they have and the ways that they're making sense of data. And in this particular example, this video is in the argumentation and discourse module, where you hear a teacher walking around the room and listening to what students are doing with the roller coaster data, and then chooses a few of the students to go to the front of the room and to share what they're doing. And the teacher had noticed that a few of the students were looking at the same variables, but using different graphical representations to make sense of them. And so she structured the conversation so that the complexity of the graphs got more complex as the conversation went on. And she was able to kind of connect and help the students learn about different ways to actually look at these several variables together to make sense of covariation, and how covariation, when you're looking at, I think it was top speed of the roller coasters and maybe the drop of the roller coaster, and how far one drops. And so it's an example of how, when you're in a classroom with students working with data and they have free choice to make the kinds of representations that make sense to them, how do you bring that together in a classroom conversation to help the whole group of students meet some certain learning objectives? And again, I'm going to skip the video because of time, but you can click on it when you see the PDF. This is the dashboard that I was referring to, where teachers can, in InStep, click on resume and go right back into where they had left off last time. And if they have taken some of the personalization surveys over here on the right hand side, they would see different recommendations of modules that are a good match for them based on what they have reported to us. So another example that I wanted to share, again, was about this orchestrating discussions. In the United States, there's a big movement of ways to actually get students involved in smaller conversations around data that don't necessarily involve the students in direct manipulation of data themselves. And so I'm not sure if there are objectives and standards in your curricula here in New Zealand about how to make sense of some of the complex data visualizations that we see in the media, but that is certainly standards in the United States. And so, if you're a data investigator and you're doing the data investigation yourself, you're involved in these different processes. But when you see a data visualization that was made by somebody else in a newspaper or in social media, then you're seeing the communication that person or that group is trying to disseminate. All right. And they made a visualization and they're telling a certain story with that visualization. So in order to really make sense of that, you have to draw upon these other pieces of the puzzle to try to dig in and make sense of it. And so we developed a framework for discourse that can support students in that kind of conversation in the classroom, so that they're making sense of visualizations that other people have made in ways that make sense. So we're going to try this. So I went and found this particular visualization, and it actually is a little blurry, but it's weekly registrations of low emissions motor vehicles here in New Zealand. All right, so I want to give you a moment to take a look at this and think about what you notice and what you wonder. And maybe you can put a few things in the chat. And let me see if I can pull up my chat. I am working on a single monitor. But here we go. I've pulled up my chat. So if you can tell me some things that you notice or that you wonder about this graph. It goes from 2018 to 2024. And it's weekly registrations of low emissions motor vehicles. And this was in a news article here in New Zealand. So Christmas or summer, fewer people buying cars. What changed in mid-2022? Yeah, we see kind of a jump here in mid-2022. Yes, we see some spikes happening. The tariffs incentives came in. Yeah. Yeah, the total gap in 2020 in 2020, no new registrations that week. Wonder which week that was. Yeah. So, thinking about this, there's a lot to kind of unpack in a visualization like this. And so what we try to do with our framework is try to help teachers and help students be able to phrase questions to help kind of unpack what's going on. So for example, what do the colors actually represent? So you have to look at the legend and think about what the different colors are representing here. So blue is a zero emission vehicle, all right? Vehicles that have no emissions in them, whereas the dark green have moderate emissions. And then the other shades of green are low and very low emission status. But, what is the significance of the vertical green lines? So in mid-2021, there's this green line that says CCD PH1, all right, which was the clean car discount phase 1. Yes, I wish those vertical lines were a different color too. Yep, I think even like red, something highly contrasting would be much better. So we might have some advice for these visualizers. But so there's questions about just reading the visualization. How do you make sense of actually what is being displayed here, and what the different colors and the different things mean in this visualization? But then there's like digging a little bit deeper, unpacking the context and the history. So, were there many low emission vehicles available for purchase in 2018 and 19? So, there weren't a large portion of the registrations were low emissions, but were there a lot of vehicles even available to purchase? What was the price of them? Coming from the United States, I'm wondering, well, what exactly was the clean car discount? And how much was it? And what exactly are examples of moderate, low, and zero emission cars? And who can actually afford these vehicles? So, how is that connected to the social aspects of purchasing vehicles? And then there's this aspect of personalizing the data. So did you or someone in your family actually register a low emission car in the past 2 years? Or any of you part of the data points that are shown in this graph? And then how do you feel about, carbon dioxide emissions in New Zealand and the ways in which New Zealand is trying to tackle these, both here in New Zealand as well as globally? Graphs make us data. There are feelings behind it. They can evoke strong emotions, and we need to be able to have time and space for that, because outside of the classroom, when our learners are facing reading newspapers and seeing things like this in social media, they do evoke emotions. And so having the space to be able to talk about those in the classroom can help with that. And honor that, and then thinking about the communicating and proposing action, who should we show this graph to, and what new data might we want to collect to further investigate the impact of the clean car discount? And so it can lead us to further investigations and wanting to actually go and collect more data. So again, this URL will take you to a one-page handout where we have, and I think someone before was putting in some of the URLs that you can get this one-page handout that actually suggests to teachers the kinds of questions that they can use to help support making sense of these data visualizations. So all of that is just to give some examples of how I try to take the research by myself as well as by others, and the good work that happens by others, and put it into a format that is usable and translatable to get back to teachers, and that is useful for them in their classrooms. So with the STEAM project that happened in 2016, that was very much focused on pre-service, university-based teacher preparation programs. And then the InStep project is very much focused on practicing teachers, those that are out there, they're in the field, and they're actively teaching and trying to learn how to teach new standards and objectives that come along. But coming back to pre-service teacher preparation, the gang got back together, myself, Bill Finzer, Stephanie Casey, Rick Hudson, as well as some of my colleague Jima Majika at NC State, and Emily Thrasher, and some of our graduate students, to really think about how STEAM can go to that next level. That if we're going to start transforming what undergraduate teacher preparation looks like in the United States particularly, we've got to have much bigger efforts and really think hard about how to help one another. And so we do have this large goal. We've just started this project. And I'm going to skip this. And we're through this, we're partnering with projects that some of you I'm sure know about, like the Intro to Data Science curriculum that came out of Rob Gould's work, the ASA, the National Council of Teachers of Math, Dennis Pearl and the group at Cause, obviously are the folks at CODAP. Folks in the United States that are starting this effort called Data Science for Everyone, as well as efforts like Math Teacher Education Partnerships, that is not focused at all on statistics and data science, but is focused on getting math teacher educators to partner together to actually help inform their practices within different university programs. So by tapping into these different partners and networks, we're sending our tentacles out to lots of different groups, and they're also informing and coming together with us in different capacities to make sure that all of our efforts are being informed by one another and that we can actually work together. One of the new exciting things that we're doing with the CODAP group, that if you've been using the sampler within CODAP, in about 6 months, you might look out for some new enhancements to the sampler, where we're going to be able to support multiple devices and chaining those devices together so we can do much more complex modeling problems, including searching with or without replacement and running samples until we get a certain outcome. And so it really opens up the kinds of problems that we'll be able to actually simulate using CODAP. And we're very excited about how this might be able to impact teaching and learning at some of the upper levels of modeling. And so not only are we in the ESTEAM project working directly with teachers, but we're also working directly with teacher educators, faculty, and those who work for different state departments that facilitate and work with teachers. And so we're going to be doing lots of different webinars. We have an online resource hub that we just launched, and that URL is there as well. We're going to be having conferences and different convenings over the next couple years, creating different facilitator guides to go with some of the materials that we've developed. We have an active, it's hopefully will become more active. We have a Slack community, and then also doing in-person workshops. So the momentum is building in the US for data science, and just recently, I just wanted to let you all know that the National Council of Teachers of Mathematics put out a position statement saying that data science is rigorous, and that it should be able to be a significant part of a high school student's mathematical experience. And that that students should have the opportunity to take 4 years of high school math, and that data science content should be available to all of them. In order to complete their math graduation requirement. This is a huge step in the United States. So, one of our national organizations saying, hey, we recognize data science is important and we want it to be part of the high school math curriculum. But it's not just that. I actually worked on this committee across these 5 different organizations. And many of you know Anna Bargagliotti and Donna Lalonde from ASA. The 3 of us were on this committee, along with members of these other organizations in the United States, the Science Teachers Organization, the Social Studies Teachers Organization, Computer Science Teachers. And together, we started talking about the ways in which our disciplines use data. And we came out with a statement in April that really says that data science bridges disciplines, and thus it needs to be introduced across the curriculum. So data science just doesn't belong in the math curriculum. It belongs in all of the disciplines. And that I think that this type of position statement is going to help us cut across different disciplinary boundaries in the United States to help us work together so that social studies learners can learn about different historical events through looking at data. The science teachers and students of science can learn different scientific principles by looking at scientific data. So I just want to end by thanking all of the funding agencies that have funded me over particularly the last 10 years, from the National Science Foundation in the United States, the Hewlett Foundation, which funded a lot of our work with the MOOCs, and RTI International. And without all of that support, we would not be able to have been creating all of the different resources that we have over the last 10 years. And so I have huge gratitude for that funding. I hope you'll stay connected with me. And I am going to stop sharing so that I can see you all again, because I only had one screen. I could not see people and present at the same time, which is very disturbing to me. And I am happy to take any questions in the last few minutes.
Thank you so much, Hollylynne. That was amazing, really, really informative, and it's really impressive the amount of work that you've done in the field and the impact it's had and is having, and really encouraging, I think, to see those position statements at the end. So thank you so much for sharing.